Hello everybody, I'm Simon Navin. I'm the Programme Manager within the Smart Practice at Ordnance Survey. The Smart Practice is part of the Innovation and Outreach team, which is one of the divisions within OSGB, which is focusing on delivering our public task and also looking at geospatial content of the future as well as our existing product roadmap. I'm going to talk to you today about some of the work we're doing within the Smart Practice and how we're delivering on a project called CityVerve, which is based in Manchester. But very quickly, I just want to run through our work within SMART and why we think geography and location is so important to delivering smart city solutions and solutions within smart environments. We believe that we are enabling and creating a differentiated and connected digital economy, and we're doing that through the creation of authoritative, exportable methodologies that deal with location data and geospatial information. And to do that, we're having to integrate a number of complex third-party location and semantic data sets. And we believe that this forms effective collaboration and underpins new technology areas such as 5G, the Internet of Things, BIM, Digital Built Britain, and connected and autonomous vehicles. And ultimately, all of this is about improving the quality of life for citizens and also reducing the cost of public services to local authorities, governments, and nations themselves. And it's about enabling connectivity, and we believe that connectivity is cumulative. If we're to reach people ultimately at the top of our pyramid here, then we need to underpin them with a connected economy, such as things like land transactions and using natural capital and security and resilience, connecting their assets, and this can be achieved through things like Digital Built Britain programme and BIM, creating a connected environment, so enabling ubiquitous connectivities through advanced connectivity solutions such as 5G and LoRa, connected mobility, so autonomous vehicles, connected vehicles, and mobility as a service. And all of this underpins what people receive, and that could be through the Internet of Things, it could be improving their health, it could be around issues such as air quality and how they move and around the city. And we're doing this through exploring a data model which is more authoritative, it's federated, so it brings in other data, it integrates with other sources, and it's extensible and secure. And really it's about something that can interpret all the different versions of the real world that we see digitally today. And it's about looking at our data and making it more machine readable and able to be consumed in machine driven environments, as well as being consumable for people on the ground. We believe a geospatial framework can allow all this to happen, and it creates these reliable opportunities and creates new opportunities for people to use content and data. Location is everywhere, everything happens somewhere, so we believe that by using location as the common currency and location as a data set that can unlock the value of other data sets, we believe there's this uniqueness that can be achieved through the work we're doing within SMART. To be trusted and to be the trusted advisor that we seek to be both to government and to our partners, we need to be really at the top of our game, and we really believe that standards play a part in this. We promote the use of open geospatial standards across all of our content. And this really isn't just about consistency or compatibility, it's about the interoperability of different data sets within that framework. And interoperability is, to us, is about being able to use many different versions of the real world, many different ways that data is described, and to understand that and accept that people will do things differently, but our content and the work that we do needs to be able to work with all these different versions of the world. Because open standards do promote innovation. We're working with a number of different partners who use our content and other geospatial content, and we want them to innovate on top of that. We want them to create solutions which people can use, they can consume easily, and we want them to be powered by geospatial and location data. Interoperability really does maximize the value of data and creates many more opportunities for people using content. Specifically today, I want to talk about the work we're doing in Manchester within CityVerve. You may have heard of the CityVerve programme. CityVerve is an Internet of Things demonstrator project, sometimes called a Smart City demonstrator project, and it's partly funded by UK government through the Innovate UK funding programme. We are one of 21 different partners within the programme, and it's a very broad range of people involved. It's led by Manchester City Council, and it focuses on an area of around 4 square kilometres in the innovation corridor to the south of Manchester city centre. We're working with partners as diverse as Cisco and BT at the large corporate end, large global conglomerates who are systems integrators, right the way down to startups such as Sparta and SatSafe and other organisations within there who fall within the middle of that kind of broad range of partners as well. What this means is we get a really interesting view of how people work, and one of the key benefits within CityVerve is understanding how all these different types of organisations are going to have to work together in order to deliver different solutions to cities. And we're developing our credibility within a project like CityVerve by using location and geography to underpin the reference architecture of a smart city. So we're trying to develop and understand different ways for people to consume our content and looking at the geospatial content of the future. What things will people need in order to underpin IoT or smart or a digital built Britain or autonomous vehicles? And we want location and geography to be embedded into a smart city at the earliest possible opportunity. And CityVerve is giving us an opportunity to do that. And it means we can encourage the need for spatial frameworks. And that means that people can use different types of location data from different sources, but they can understand that it will be authored, that it will connect, and it will be interoperable. And what we're doing in the project is we're going beyond what we would normally do for our data capture standards. We're creating what we believe is the most advanced digital representation of the area. We're building an environment whereby people can access our content and it can be read by machines and it can be delivered in many different ways to support the deployment of sensor technology and also the solutions that people are going to use. Through our capture program in CityVerve over the last 12 months, we have taken a different approach to data and to the data that we see on the streets. We've captured something in the region of over 40,000 different assets at the street side, and this can include things such as road signs, yellow markings, car parking bays, bins, waste location points, bus stops, in more detail than we've ever done before. And what that means, if we combine that with the data that we capture as part of our standard specification, we create a more unique view of the city than we've ever seen before. So we can have things like functional sites operating alongside highways data and network data, building that in with address data and detailed polygon information about parking bays or road markings, as well as all those point-based information such as bins, lampposts and road signs. We get a very rich understanding of how the city looks, and that gives us an opportunity to share that data with our partners so they can start to look at solutions using the infrastructure to deploy Internet of Things technology and sensors. But why bother doing this if there aren't some solutions? Really, we need to solve people's problems. So we're going to look at a couple of examples here about how we're using our data to potentially solve some of the issues that a city faces. One of those is around parking. We all know the issues we can have driving in and around the city, about where will you park, how much will it cost, how many spaces are available. We're working with real-time information coming from Manchester about the capacity and availability within car parking bays in and around the city. But we're going one step further by using geography to look at the size of parking bays, the size of car parks, and starting to play tunes with real-time information in and around so we can flex how many vehicles can come in and out of a car park, whether the right type of vehicles can come into certain parts of the city. And that gives the city different opportunities to look at how vehicles are affecting air quality or how busy traffic can be. And this has a knock-on effect to some of the other areas of CityVerve, such as looking at how health professionals move around the city. We want to ensure that they've got the most opportunity to move around, and if you start to connect up some of these different solutions across all the different themes, then you get a more effective solution for the city. So it's not just about improving car parking for a certain demographic, it's about improving car parking and transport and health all across the city, making all of those different agencies work together more effectively. Another example is within urban navigation, using digital wayfinding. Working with a number of different partners such as Republic of Things and Sparta, we're providing information into them whereby they can start to look at shorter journeys within a city. Many of us take for granted some of the things we do when we travel around the city, but often people who have visual difficulties or other mobility challenges might find it more difficult to move around the city than you and I. And in this simplified 3D example, you can see some of the richness of the data that we've captured. So all of the red information you can see as a polygons, such as parking bays and road crossings and road markings, and all of the blue poles that you can see are all the different street side assets, such as trees, lampposts, road signs that exist in and around the city area. And we've captured thousands of different objects, such as the location of tactile pavings, pedestrian crossings, all the crossing control points, as well as the infrastructure that controls signalling. Now, for you and I, a simple journey of a couple of 100 meters from our home to a bus stop, that we might take that for granted. But for someone who's got a visual impairment or doesn't understand the city well or has some mobility issues, this can be a real challenge. So in this example, we've mocked up a very simple journey, how someone might move from their home to their bus stop. And we can see that on screen, that looks quite simple. It looks like it's a fairly easy journey for someone to take. However, there may be a number of obstacles along the way that would affect their journey. And by having this rich information, by having all the data available to us and available to our partners, we can start to see how we can use that data to create something that can give warnings or provide information about some of the obstacles they may face along the way. And this data is being used to create digital wayfinding solutions, possibly using things like wearables or digital signage to provide nudges to people in and around the city about the journey they take. And ultimately, it's about providing a better solution for people and improving people's lives. The knock-on effect of things like this is it can improve mobility around the city, which means people can get to places faster, they might be able to get to work faster, they may be able to do more walking and feel more independent. And that has benefits as it knocks onto the health service and also to the transport service in and around the city. Another example of where we're using geography and location data is around the deployment of sensor data and sensors themselves. So in this example, we have surveyed and located thousands of lampposts in and around the city, and by deploying some fairly standard GIS techniques, we can home in onto different lampposts of different heights, particularly if we're looking at the deployment of air quality sensors. Now in this example, we start to ask questions of some of the data. So a city may want to plan for the attachment of air quality sensors. They want to see where all the ones in and around a certain motorway might be and how high they are, and look for some information about those. By having this data, they can start to see who might be affected if there's a maintenance contract in place to deploy the air quality sensors. They can start to understand what roads might be affected by this data. And that means you can start to have a view on what the effect on the transport network might be once you do the deployment, and also what effect you might have by having other vehicles passing in and around that sensor data. In this example, we can see which lampposts already have air quality sensors attached. When we start to come to look at the analysis of the results, this could be really important for people who are starting to move through the city. As we share information about green spaces and air quality in the data, people can make choices about how they move. That could be somebody driving to work, they decide to take a cleaner route to work and they don't want to affect the air quality, or they could choose to take public transport, or it could be somebody who's just taking their child to school and they want to take a cleaner, greener route through the city. By having the information available to them in real time, they can make that choice. In this video you see, this is an example of some of the content that we've captured. So all of the data you've seen previously lives inside a model where we're sharing with our partners. But we also appreciate that there's a need to understand the city visually. So we've captured very rich data from the air and from the ground about the city and put this information inside a 3D model. This allows people to orientate themselves, understand the city, recognize parts of the city that they come from. And as you start to layer solutions and data over the top of this, people can really feel that they're part of the city and part of the solution. The visual aspect is important, even though it's not everything. It's the data that underpins the city and data that underpins the model, which is most important. But it's really good for people to be able to connect with their city in different ways. In this next example, you can see some of the model data that we've captured down at ground level. In order to be able to pull the richness of all the data and the street side information in Manchester, we carried out some mobile mapping using a vehicle mounted with a laser scanner. And that's allowed us to capture something in the region of 5 or 6 billion individual points about the city in 3D. And from that information, we can start to extract both location, geometry, and attribution about the different street-side assets. And having such a rich data set as this means we can go back to it time and time again and start to pull more information from it, should partners or should solutions require that. That could be things such as materials on buildings, it could be the size of trees, it could be things like how vehicles are moving in and around the city and where some of the parking restrictions might be. But the key for this project is it's not just a reality for Manchester. CityVerve is about creating a blueprint for cities worldwide. And one of the key aspects of this project is it has to be scalable and replicable. And it allows us to take the solutions into other cities. We're already working with Adelaide in Australia to look at how we're going to deploy some of the solutions. And we're looking at how we can turn our content and the data that's underpinning the smart city into a digital twin. And that digital twin is something that exists in harmony with the physical world. And the idea being that if you make changes to the digital model or to the physical model, these two things can happen in real time and work together. Just very quickly now, having spoken about CityVerve, just want to draw your attention to a couple of other projects that we've worked on in the past year or two around smart cities. The first being Espresso. Espresso is a Horizon 2020 funded project which is looking at standards and business models for smart cities. And it's about the reusability of that Espresso architecture. Again, it's about ensuring that location and geography is at the heart of the reference architecture for smart cities. In combination with CityVerve, we're working on the Petra project. Petra stands for Privacy, Ethics, Trust, Reliability, Accessibility and Security. And it's about investigating new ways of protecting privacy. And our role within there is the subject matter expert around location. Location can be one of the last pieces of a jigsaw that could expose someone's privacy, and we don't want that to happen. So we're looking at how Internet of Things and smart city technology can be secure and how the location aspect can ensure that it doesn't expose someone's privacy when it's merged with lots of different data sets. There is a real risk around security of data as we start to bring all these different data sets together, particularly information about individuals' health or their mobility. So we want to ensure that there's adequate privacy and security layers within the data that we use and the data we use from others. The Future Cities Pilot is a project that we work with the Open Geospatial Consortium, which we're a strategic member. And this was an opportunity for us to build some demonstrator tools using very granular BIM data down to each rivet and door which is constructed within a building. And how that works within city environments using the City GML data format. And that allowed us to look at things such as how housing could affect someone's health by taking in different data sets from across the city, but also data sets about housing stock and also people's health conditions. And this allows a city, again, to make decisions about putting the right people into the right housing at the right time, or the maintenance schedules that need to carry on with those housing. Atlas is a project we're looking at and we've been working on around intelligent mobility, about powering connected autonomous vehicles and the data exchange models that need to exist as those vehicles start to pass information between themselves. Lots of data is going to be passed between autonomous vehicles and we want to ensure that there's some standards, particularly around the location of the vehicles and the data and the infrastructure when they do that safely. And the 5G project is a project we've worked with DCMS in the UK, which is a demonstrator project for showing how 5G can be affected by geography, and it's a planning tool in order to deploy 5G sensor networks and 5G data networks, and seeing where those hotspots and not spots for coverage may be. And this has real global relevance. 5G is obviously one of the new forms of advanced connectivity, which is going to carry very, very detailed information and lots of data through its signal and through the way it's deployed. But it can only work over short areas and is quite unstable. So understanding the geography as you start to propagate that network data is really important. And finally, the project I want to just cover off at the end is the Digital Built Britain programme. This is looking at how the UK addresses productivity challenges through the optimisation of built assets in the entire life cycle. So this is the next generation of BIM, but looking at BIM on a national level. And our role as a subject matter expert within that is to advise on geospatial. So all the different digital representations of the real world, specifically including the built environment and the natural environment, we need to be able to ensure that all of those work together, that the way that things are described in the real world and how they're located and the way that they talk about different objects, we need to ensure that those are both consumed by humans and machines, and that the geospatial framework and the location standards within those models and within those objects is available to everybody and allows for interoperability and ultimately innovation. Digital Built Britain, supported by location data and supported by geospatial, really will contribute to reductions in whole life asset costs, give that greater understanding of the environment and improve productivity and ultimately power those new technologies we've discussed previously, such as autonomous vehicles, 5G, the Internet of Things in projects like CityVerve and BIM. That's all I want to say today, so thank you for listening. I hope that's been helpful.
So I've got one question about, are you looking at how the transactional ability of blockchain can improve the efficiency and ability to collect city data?
So thanks for your question. So we are exploring blockchain and what it can offer us in terms of its transactional ability. We're particularly looking at it around land administration and land registration, but we're looking at many different opportunities within it, and the efficiency of collecting city data is an interesting area which I'm sure we will explore. But blockchain is something that's very much on our radar, and as we move forward into Digital Built Britain and as we move forward into developing a real-world object model which can link with many other data sets and link with more things in real time, we think blockchain definitely has a role to play within that. So we've got a question here about the style sheet for the slides. So that's been styled internally, and using our data, you can style that information yourselves using different styling techniques within things like QGIS. Some of our CartoViz guys within OS have chosen this style because they feel it's quite effective, but I don't think it's available as a map as a style sheet, but I think it's something you can do yourself within different packages.